Question 20. Events A, B, and C are independent but not mutually exclusive. A, probability of A is X, probability of B is Y, and probability of C is Z. Express in terms of X and or Y and or Z the following. The probability of A intersection B intersection C, and the probability of A union B. Right. Let's consider a little illustration here. Supposing we have person N, or person M, who could choose 4 numbers, 1, 2, 3, 4, each with equal probability, and person N, who can choose 10, 20, or 30, each also with equal probability. And we define event A as M choosing the number 4, and event B as N choosing the number 30. So the probability of A, let's call it X, is just 1 over 4. Because, M can choose one of 4 numbers, and the probability of, M equals 4 happening is just 1 over 4. Similarly, the probability of B, which is N choosing 30, is just 1 out of 3, or 1/3. The probability of A intersection B means the probability of M choosing 4 and N choosing 30, both happening at the same time. Let's look at the grid here. M can choose any of those 4 numbers, and N can choose any of the 3 numbers. This box gives you the total of number of combinations of choices between M and N, and there are obviously 12 possible combinations, each of them equally likely. So the probability of A happening, which is 1/4, which is these 3 boxes, which is 3 boxes out of 12, which is 1/4, and the probability of N is 1/3, which is 4 boxes out of 12, which is 1/3. The probability of A intersection B means the probability of M choosing 4 and N choosing 30, which is basically this little box here. Yep. And of course, we can see that the probability is obviously 1 out of 12. But more formally, we can write this as the probability of A times the probability of B, right? And that's X and times Y. And this happens to be, in our example, 1/12. And we can also see that from this grid that it's obviously 1 out of 12. Now note that M and N are independent events, which because whatever M chooses doesn't influence what N chooses, and vice versa. But they are not mutually exclusive, which means this event A of M choosing 4 and N choosing 30, they can happen at the same time, so they are not mutually exclusive. So this is for intersection, which means both events happening at the same time. Union, the probability of A union B, means that either this intersection you can think of as and, or A and B happening, and a union you can think of it as or A or B. So what is the probability of N choosing 30 or M choosing 4? In other words, either one. This would be these boxes. So we're going to tick these 4 boxes and tick that 3 boxes as well. So we can see that There are 6 boxes here out of 12. That's obviously half. But if we didn't have this box, then we would say that this is the probability of A plus the probability of B. Basically, adding that row and that column and subtract the intersection, which is the probability of A intersection B. Since you double counted this one, we have to subtract that one box. So that is simply x plus y minus xy. And that's simply, in this case, 1/4 plus the third minus 1/12. So if we rewrite that, we get 6/12, and that's simply half. So in summary, intersection means and, so you multiply them. Union means or, and you add them and you subtract the intersection. So now we come back to the question proper. And based on what we've learned, PA intersection B intersection C is just PA times PB times PC. So that would just be X times Y times Z. And that's the answer. PA union B, however, it's going to be PA plus PB minus PA union A intersection B, which we know is just PA times PB. So that's going to be X plus Y minus XY. And that's the answer for part B. Question 21. Given the graph, y equals to mod n sine alpha cos alpha for alpha between 0 and 2 pi. Part A, express m in terms of n. And part B, there are 8 solutions for y equals k, where k is a constant, so state the range of k in terms of m. So let's look at the graph. The equation is mod of n sine alpha cos alpha, and this can be written as n over 2 mod 2 sine alpha cos alpha because the constant, you can take out the end, and you can just factor out the 2. And we notice that 2 sine alpha cos alpha is basically sine 2 alpha, which has 2 cycles within 2 pi. And because it's mod, therefore everything is made positive. And therefore, we see that from the graph, we've got 1 cycle and you have the second cycle, and all of it is made positive. And the amplitude of the sine graph is m. The amplitude of this sine graph is n over 2. So we can conclude, therefore, that n over 2 is m. Therefore, you can state that m equals n over 2. And that's the answer for part A. For part B, we just have to state the range of values of k for there to be 8 solutions when y equals k. Now, when y equals k, the line is simply a horizontal line. So let's just draw a horizontal line, an illustrative horizontal line, maybe something like that. Okay, so let's state that as y equals k. And we see that we have 1, 2, 3, 4, 5, 6, 7, 8 solutions. So for there to be 8 solutions, k must lie between 0 and m. And that's the answer for part B, for 8 solutions. Okay, notice that it doesn't include 0 or m. Yeah, so it's less than and not less than or equal to. Because if it equals to 0, then you have 1, 2, 3, 4, 5 solutions. If it's equal to m, then you have 1, 2, 3, 4 solutions. So we have to exclude the endpoints of 0 and m. So therefore, k lies between 0 and m not inclusive.